Okay, today is March 30, 2022. This is the meeting of the Container Storage Interface Community. As a reminder, this meeting is public, recorded, and posted on YouTube. So let's go ahead and switch it over to the agenda here. I think the main topic I wanted to discuss was whether we're ready to cut another release of CSI or not. Anyone else have any other items they want to put on the agenda?
Yeah, I had a quick one. I can go ahead and add it, I guess.
Yeah, go for it. So for the CSI one, we've been waiting to fix the, so the Travis CI was, they basically shut down, so we have to switch to a different CI option, and Andy went ahead and added GitHub Actions. So I merged.
Wait, did you say Travis CI is gone?
I think Travis CI shut down their travisci.org offering, and they switched to a travisci.com offering. And so we've been using the .org offering so far.
So the company's business model changed or something and we just can't use it?
That's my understanding, yeah.
Okay, that's news to me.
So
it's not free anymore.
Yeah.
Okay.
So
I mean, everyone's got to make money.
Yeah, we already switched that from our Kubernetes CSI org.
Yeah, and on the CSI side, I think this was disabled for a while, and we merged Patrick's changes, but we didn't have any CI. So Andy went ahead and added GitHub Actions. I merged that yesterday, and there's a follow-up PR here. So I guess my question is, are there any other outstanding PRs or issues that we hope to get in before I cut a new release, or are we good to go after the GitHub Action ones?
Yeah, I'm not aware of other things other than this. So he has 3 more. Okay, good.
Yeah, and they're, kind of.
Oh, those are not like critical. Okay, but just good to have.
Yeah, I'll go ahead and merge those, but
okay.
And feel free to take a look at the open ones and LGTM them as well.
Sure.
Okay, so then I guess plan here is Saad will merge open CLs from Andy to release today. Oh, well, so there's a caveat to this. So we can't just cut the release today. We'll cut the release proposal, the RC today. And then 2 business days from now, we'll get the real release. Okay, sounds good. Hopefully that gives enough time to still be able to pick up the changes in external provisioner next week or so. Okay, let's go ahead and switch to your topic, Deep. You want to talk about this?
Yeah, sure. Thanks. So basically the idea I was trying to explore is today in at least Kubernetes, I was wondering, is there a generic way or is there a need for, given the same persistent volume, is there a way for the plugin to make like specific choices on the mount options that it uses during node publish, assuming like a block-based volume plugin, and tuning it to certain aspects of the pod? So right now, Kubernetes already offers the pod name and the namespace. And so if the CSI plugin decides to have a client to the API server, it can query and get like all aspects of the pod, like pretty much the pod object. But of course, that is not very efficient. One thing I was wondering is like, one simple solution could be like if the pod can pass down, or like if the kubelet or a container orchestrator can pass down a bunch of annotations or fields from the pod, that solves this problem as part of the node publish context. Today, the contexts received are the ones from the creation of the PV, but not necessarily from, like, that's not influenced by the pod that is mounting the volume, right? So I was wondering if there are any thoughts around that area, and would it make sense to explore a path where, say, a known set of annotation or fields on a pod would be passed down to a CSI plugin during, say, node publish?
What are those annotations are for though?
It's basically going to, like, maybe it could be something like the names could be prefixed with something like a CSI prefix or some prefix that we come up with. And the annotations could be something like, it could be pretty arbitrary, but essentially specify something like, I like the pod, maybe it does not need certain journal checks. It can,
Well, so Deep, it feels like there's two different sides of this question, or maybe more than two. There's one question of can the SP have mount options that vary per volume or per attachment or per node or something, which is a question about how the SP works. And then there's a question of, if it can, how would one pass those down through the CO?
exactly.
Right. And you're talking about the second half of it. I mean, I think it is the case that SPs can do whatever they want with mount options. I mean, there's mechanisms for the CO to suggest mount options to the SP, but SPs are ultimately free to ignore them or override them or modify them however they want. Unless someone disagrees with that, like that's my understanding, is SPs treat the mount options that come down from the CO as a recommendation, but they're not required to follow them exactly.
Agree. But like, let's say if
Okay.
completely agree with that, man. Yeah. But let's say if the SP wants some hints from the pod, is there a mechanism to pass it today? And
Right.
not, would it be worth exploring?
And I also think that, like, one could implement some sort of a hack in the CSI plugin where the CSI plugin would go contact like a Kubernetes and go read volume annotations or read pod annotations, and you could go get that information through some sort of a side channel and
Sure.
use it. I think that would work today.
Yeah, that
So,
already
like,
is there. Correct.
yeah. So technically this is totally feasible. But then where we always get stuck is like, is this something we want in the CSI API, right? And that's what you're basically proposing, is some official way to pass these through.
Like, we have the context from the creation time, but no context from like a specific publish, is essentially.
Yeah, and it gets challenging with publishes because you can have multiple pods on the same node, and they could have conflicting desires, but because of the way SPs are usually implemented, that like the actual mount tends to be shared. Just because, like, if it's like an iSCSI mount, for example, you're only going to mount it one time and then bind mount it out to all the pods that want to use that particular volume on that particular node. And so you could have situations where it's not even possible to give different pods different mount options if they're on the same node,
Yeah.
right?
Yeah, I agree. There could be conflicts.
Okay. So, like, I don't know, it seems like you'd want to resolve those kinds of problems and figure out what is the use case that this addresses that can't be solved any other way, or that is best solved through some sort of official API.
Sounds good. Yeah, essentially what I was looking at is the history of this. For example, I think we are trying to pass down certain things like, say, the FS group today, based on like a pods requirement. And that's like, if the SP chooses like some, like, I guess in the case of NFS or SMB, then like that's a very specific thing that's passed down. And I was wondering, like, would it be useful to kind of have a generic mechanism for that to pass down arbitrary set of pod attributes without the API server channel?
Yeah, the FS group had a very specific use case where like stuff just wouldn't work without it.
Yeah.
And so that was the motivation to add that.
Yeah, in general, we
Is-
try and avoid kind of poking holes in the API where you can pass arbitrary information,
Okay.
especially from, grabbing a bunch of annotations or labels and passing those through to CSI. We've discovered in the past that that ends up kind of being a mechanism that folks use to not invest in CSI or the kind of ecosystem around Kubernetes storage. And so our suggestion tends to be, let's talk about the specific features that you're interested in and see if there's a better way to add those features into CSI and Kubernetes.
Got it. So in general, like specific fields are preferable with like adjoining use cases rather than like a generic mechanism to pass down arbitrary things, right?
Yes.
Okay, got it. Cool. Just needed some guidance and suggestions on this. Thanks.
Sounds good. Good discussion. Okay, let's move on to the next one. Ben, you've got mixing of access modes.
Yeah, so this is just something that I stumbled across the other day. Excuse me, I'm having lunch right now. I noticed that, obviously in Kubernetes, access modes is a list, and you can have more than one, although that's pretty uncommon. You could mix something like RWO with ROX. And it is the case that individual drivers can support more than one, although not necessarily at the same time. But then when I tried to test this out in Kubernetes, I discovered if you create a PVC that asks for both RWO and ROX at the same time, you get rejected. I think the sidecar just vetoes it and says, no, I'm not doing that. And so I wanted to talk about why and what the thinking is around mixing of access modes and what should be allowed and what shouldn't be allowed and what makes sense. So was anyone else aware that you can't request a mixture of RWO and ROX at the same time?
What would the intended behavior be there?
Well, the thinking is that for a particular volume, it could either be written by one node or read by multiple nodes. And if you think about how you would implement that, as long as the volume was in one mode or the other at any particular time, it's always safe to do so, right? The challenge would be ensuring that you never have a situation where one node is writing and another node is reading at the same time. So you'd have to basically lock the volume into one mode or the other, but it could change, it could swap back and forth over its lifetime in principle, right? You could imagine a situation where you had a volume that was meant to distribute a bunch of data and you create it empty. You create one pod that fills it up with data, you shut that pod down, and then you go create a bunch of other pods that all read the data. And that would be a mixture of an RWO and an ROX style of access mode for one volume, but not at the same point in time. So like, I guess what I was trying to figure out is, given that the underlying technology can do this stuff, and given that Kubernetes has the capability to express mixtures of access modes, like, are there other places where you can actually mix multiple access modes and get good results? And it's just that CSI didn't want to go there because it's very complicated.
Yeah, I think the background here was before we had dynamic provisioning, it was all pre-populated, pre-created persistent volumes. And so the PVCs were more flexible at that point because you couldn't just demand an arbitrary volume. You kind of had to pick from the subset that was available and to kind of cast a wider net instead of saying, oh, I want a, RWO. You could say I want an RWO, but RWX will suffice. And that was a way to be able to cast a wider net in case, there weren't that many volumes available and you could work with a different type of volume. And so access modes was a list. And so that's where it kind of came from. once dynamic provisioning arrived on the scene, it kind of took away the need for having to specify access modes as a list, because basically, for the most part, you can get what you asked for. Or if you ask for something and it wasn't possible, you get an error, and that's basically it. So that's kind of the background here. I think the use case that you're mentioning of access mode basically changing through the life cycle of the PVC is not one that we've discussed so far. It's an interesting one. I think we can talk about if and how to support it. But that was never the original intention of this list of access modes.
Yeah, well, I mean, the way access modes work at the CSI layer is they're passed in at creation time and controller publish time and node stage time and node publish time. So like it keeps telling you what the access mode should be at every point. And so you could imagine a situation where, creation of multi-access mode PVCs was allowed, and then it was the responsibility of the SP to, at controller publish time, sort of see the particular mode that was being requested and then sort of lock the volume into that mode, or fail the request if the request was not compatible with the mode the volume was currently in. And then you could imagine a volume that could be either RWO or ROX, and until it was published in one of those two modes, it was ambiguous. And then once it's published, it locks into that mode until it's unpublished from every node, and then it goes back to being flexible. So like, I think from a CSI perspective, you wouldn't even have to change anything. You would just have to, have some, I guess, example workflows that would go through this funny sequence of publishes and unpublishes and validate that you get the behavior you want if the driver purports to support that particular capability.
I think it's a
That
good
has to
idea.
be a,
Go ahead, Shane.
I was just saying this has to be a new capability then, because definitely not every driver can support this type of behavior.
Well, but
for a lot of
right.
once you just you create it, that's it. You can't really keep changing it along the way.
But I don't think the CSI spec is clear about this, and this is how I managed to get confused, is because it's always passing in a requested volume capability. The implication is that you're supposed to check the capability that's being requested every single time it's passed in. And it's not obvious that you're not supposed to support the workflow that I just outlined, right? Because CSI can pass you different capabilities and create, or can actually pass you a list of capabilities and create, and then you can get one of those capabilities at controller publish time. It's entirely within reason that you could pass in all of the capabilities at create time and then one specific capability at publish time and expect it to work. So like in terms of advertising the capability, I think merely allowing someone to provision a volume that asserts both the single writer and the multi-reader capability would be the signal back to the CO that, yeah, you can do this, right? I don't actually know what Kubernetes passes down at create time and for that list. I should go look. But I think the capability negotiation between the CO and the SP is already fairly elaborate. And if one wanted to do this, it could probably just be done. But you would have to have the Kubernetes sidecars, actually send the right things and allow the right things. This isn't a super high priority for me. It was just something I investigated last week when someone was asking me about ROX and RWO, and I was like, oh, I wonder how that works. And I tried it, and I was surprised to find that it's blocked at the Kubernetes layer, not at the CSI layer.
Yeah, this is a great scenario, Ben. Like we use this scenario quite a bit in like a lot of our use cases, or by a lot of our customers. The way we get around this is a very ugly hack. Like we just declare everything as ROX and then kind of allow writes to seep through from the populator pod so that
Ooh.
yeah, it's like really bad. It's mainly because like I think for the PVC you cannot change the access mode, correct?
Right.
Right. So that's why we have to kind of lock it to something and then depend on a hack to get around the fact that it's immutable. The access mode is immutable.
Yeah, I think it's a
Okay,
neat
so
idea. If you want to kind of prototype it, I think it would be fairly easy to prototype just by modifying the sidecars to allow it and see what happens. And then
yeah,
come back.
and the real question would be, can we rely on the existing volume capability negotiation that happens at create volume time to allow the CO to detect that the SP can do this or not, right? To answer Xing's concern, you need a way to say, I don't support this if you can't do it. And I had assumed that the existing capability scheme did that, but there could be bugs. So, and I'm sure people aren't testing this today, which is why I was saying, yeah, if we went down this road, we would want to have a test that you could exercise your driver and see if it worked or not. Okay, so it sounds like someone could write a prototype. I don't know if it'll be me, but yeah, it was just a strange thing that I noticed, and I thought I'd bring it up here.
Yeah, agreed.
Okay,
It's
one clarifying question. So it's not just the sidecars, like Kubernetes itself will need the ability to change the PVC modes, right? Like from
No, this isn't. So in Kubernetes, you can create a PVC with both RWO and ROX access modes, and the PVC creation will go through. But then when the provisioner sidecar sees that PVC, it'll say, oh, I see there's more than one access mode. I am not going to provision this volume.
Oh,
So,
interesting.
so Kubernetes is happy to let you support
Okay.
both access modes. It's the sidecar that says, I don't know what that means, so I'm not going to do anything.
But that access mode specification, like, is there a mechanism to pass it down during, say, controller published or node published to from the Kubernetes end to say that this specific pod now wants to mount this?
Yeah, that's going to be the trick. So the provisioner would have to understand what it was supposed to pass down to crate volume, which is not so hard to figure out, but you could do it. But then the external attacher would have to understand what to pass down to controller publish volume. And that's much harder to figure out because you don't know, publishes happen at different points in time and you never know what's going to come next. And so at any given publish time, you'd have to sort of know about all the other publishes for the same volume. And yeah, or you'd have to know if the intent of the particular publish was for a pod that was going to be in read-only mode. I don't know if the external attacher knows that the pod is going to be using the volume in a read-only way or not.
Exactly. Like that intent needs to be specified too somehow. Right?
Yeah, but that's all Kubernetes side stuff. Like in
Correct.
principle, a CO that was omniscient could figure this out and send it down to the CI layer. The CSI layer, and it would work fine. But the way external attacher works right now, it might not have enough data to say, oh yes, this particular publish can be read-only because the pod that is going to use it is going to be using it in a read-only way. That's hard to figure out.
Yeah, the locking that you mentioned, that will be interesting.
You said this is rejected by the external provisioner sidecar at the provisioning time if you pass into.
That's my understanding.
Okay.
But when I tried this,
what about entry volume?
When I tried it, I saw an event pop up on my volume that says CSI does not support mixing RWO.
I was just wondering
and
if it's supported for entry volumes.
I think it is. I think
it's supported for entry volumes, only not supported by CSI.
Well, for the reason that Saad said,
but
the
volume,
Kubernetes API will let you do this.
But But I thought Saad was saying dynamic versus static, right? Entry volume, you can also do dynamic, I think.
Yeah, so I don't know what they do for dynamic entry volume provisioning.
Okay.
That's a good question, worth testing.
It's going to depend on the specific provisioner, I bet, because it's an implementation choice to allow it or not allow it. The API server is going to allow it.
The PV controller, so. don't know if we have the same check there. Yeah, so I think this, I'm really worried that this will completely break our driver. We depends on this. So if it's RWO, that's block volumes, RWX, that's file volume. So I suspect something will be broken if we're allowing this. So
Yeah,
Well,
if we
yeah, I
ever
mean,
go down
today
this,
we don't allow it, and it
yeah,
makes life simple.
I just want to make sure if this suddenly
yeah,
gets
if we ever go down this path, like Ben said, at creation time, if a particular SP doesn't support it, it should immediately fail. And we would
Yeah.
need to figure out like a way to make it backwards compatible so that it doesn't affect any existing drivers.
okay.
Yeah. Okay, well that's my random observation for the week. Something I noticed. I don't have anything else.
All right, cool. Any other topics from anyone? All right, we'll give you half an hour back in your day. Thank you, folks.
Thanks, Ed.
Thank you.
Thanks,
Bye.
Odd.